Power outlets, a universal product used to connect electric equipment such as cooking appliances or power tools to the grid. Power outlets and plugs can come in many different shapes and sizes depending on the country in which they are purchased, often with differing levels of voltage. However, power outlets have been highlighted as a significant hazard for the user and have caused many deaths to children. Firstly, some outlet sockets and switches can become clogged with dust and dirt, making them faulty. This can cause the outlet to spark and result in serious injury. In addition to this, outlet plugs can be easily pulled out if the cord is tugged, which can dangerously interfere with the use of electronic products such as power tools. The main problem, however, is the direct access to electric current through the sockets found on the front of the design. This design fault poses a serious threat for children who happen to insert a small toy or paper clip into the outlet. Through secondary research and interviews with multiple parents, I came to discover that existing outlet safety covers are not effective. There are still approximately 2,400 children that are severely shocked or burned by electrical outlets each year. In addition to this, 1 in 3 children injured by electrical outlets each year are between the ages of 5 and 17. A study conducted by the Temple University found that 100% of 2 to 4-year-olds could remove a plastic outlet cover within 10 seconds. There just had to be a way to make outlets more safe. I began by sketching out the ideas I had for the product. My first concept sketch idea involved the wireless transmission of power, which later on proved to be too difficult. However, I quickly drew inspiration through the design of HoseLink, an Australian product which allows the easy connection of hoses. Drawing inspiration from this existing design, I developed a similar twist lock system which would allow the plug to lock into the outlet, preventing it from getting pulled out of the wall. I then put the design into CAD, where I was able to get a more realistic perspective of my design idea. Through CAD, I was able to ensure that the male plug would twist lock smoothly into the female outlet without any snags or friction. 3D printing prototypes took up many hours in this project, as I was constantly redesigning aspects of the product in consideration of the factors affecting design. In addition to this, there were times when the printer had errors resulting in badly printed prototypes, which forced me to reprint. I explored ideas such as a power outlet with 2 ports, however I soon discovered that this made the prototype far less aesthetically pleasing and too heavy due to its bulky design. So I decided to stick with a single port outlet. After inspecting one of the outlets in my home, I realized that they had a plastic cover that fit over the top of the outlet to hide rough edges, helping the outlet blend into the wall. As it was evident that this design aspect had considerate aesthetic benefits, I decided to incorporate this into my design. I began by finding the measurements of my design and then cutting a piece of 6mm thick plywood to size. I then used a vacuum former to mold the high-impact polystyrene sheeting around the piece of wood. This stage took multiple attempts as it was difficult to get the cover to fit properly. Sometimes the cover was too loose, and at other times it was too tight, causing the plastic to break. I then removed the plastic around the design using a scroll saw, which allowed me to cut quite close to the project. I then used a disc sander to take off the rest of the plastic. After finding the center point, I used a drop saw with a 51mm hole bit to cut a circular hole into the middle of the project. I then used a file to clean up the edges until they were no longer sharp or rough. Now that the cover was finished, I printed the outlet again, but in white this time, so that it would match the cover and blend into the wall. I then found a heated towel rack and cut the prongs off the plug. I then attached my design to the plug using hot glue, which held it firmly in place. I then repeated this same process with the plug of a laptop charger. As shown, the house outlet system requires a direct insertion of the plug and a flick of a switch to generate power. My outlet system also requires 2 actions, insertion and twist. Once the plug is twisted 90 degrees, the internal tab comes into contact with the conducting bridge, which acts as a hidden switch. This ensures that the conductant is out of reach of children, whilst also making the product look more aesthetically pleasing due to the removal of the external switches found on existing designs. Upon final analysis, this design solves many of the issues that are posed by today's standard power outlets. When locked into place, my plug design remains firmly in the outlet, keeping the connection of current even if the power cord is accidentally pulled. I tested my new design on multiple different electric products, including my MacBook laptop. Overall, this project has proved to be very successful and has fulfilled the design brief. My new design has created a safer environment for everyone, and especially children, as they are no longer able to access direct power from the front of the outlet. Despite the cumbersome changeover from existing plug designs to my new twist lock design, it is imperative that my concept is implemented, as preventable injury or death should be a priority.